Hey everyone, this is my test video for ECU 286, and this is a review of the last class when we talked about how to solve magnetically coupled circuits, and this is the trickiest of them all because this particular inductance is between two meshes, so the mutual inductance, the coupling here will depend on two currents. So I'm not going to completely solve it. I'm going to just draw what I would have expected. So this is going to be a voltage, a phasor, obviously, in series with 3J plus 4 minus 2J. So it's going to be 4 plus J. And then for now, I'm going to just leave that same 4J ohms there, and the 2J here, and 1J here, and that's where the dot is. I'm going to make this mesh slightly longer, and I'm going to assume we're going to do source transformation here and have a current source in parallel with minus 10J, and then we're going to do these two in parallel, and then go back to another V. I'm going to call this V2, V1, and there will be an impedance here. There will be the parallel of those two. I'm going to call that Z2. I'm not that interested in solving it here because I am more interested in showing you the deal with the dots. So we're going to assume two meshes here going this way and this way, and I'm going to call this I1 and I2. And now is the only new concept from chapter 13, these first sections. I will draw the updated circuit here with a current-dependent voltage supply. And what happens is the plus side is on the side of the dot. So I'm going to drop this dot here, but as you see, it's on the right side of the inductor, of that inductance, so I'm going to put it on that side. The value of this stays the same. And I'm going to copy the rest here. This is that impedance. This is that voltage supply. Now, these two are current dependent, and what happens is the mutual or I'm saying it wrong. It's actually the magnetic coupling between these two inductances, which is 1J. On this side here depends on the current through this inductor. And on this side only depends on the current through this inductor. So I'm going to do this one because it's simpler. So it's again 1J times the current I2, which is the current through the 2J, times I2. And now the question is this positive or negative? And if the current is going into the dot, so if this I2 were coming into here, it would be positive. But it's coming into the other side, so I'm going to put there a negative sign there, a negative sign. So on this, I'm going to call the current through that inductor I4, and I'm going to make it go into the knot so that it's plus 1J times I4. And then I can write I4 as a function of the mesh currents. So I4 is I1 minus I2. You could also have written then 1J times I1 minus I2. You could also have written minus 1J times I2 minus I1. So this is really the circuit that we should solve. Again, this is I1, this is I2. And you can solve this with basically two equations. And we are done. So even I4 is really a function of I1 and I2. So hopefully this is clear.